Okay, so for this question, we are going to draw a diagram first. Let me draw it properly. Okay, so this is triangle OAB. E is the midpoint of OB. So I'm drawing E. E is the midpoint of OB. If E is the midpoint of OB, then by midpoint formula, E bar should be equal to O bar plus B bar divided by 2. Second is D is a point on AB such that AD to DB is 2:1. So D is somewhere here and the ratio is 2:1. From here I can again find out D bar. D bar will be equal to 2 times B bar plus A bar divided by 2 plus 1, which is 3. Now what I can see here is, this is section formula, okay, by the way. Now I can see here that B is the common point between AB and OB. So I can say I can bring both of these formulas in terms of B. So now let me put it in terms of B. So for the first formula, which is this one, B bar is equal to 2 times E bar minus O bar, right? And for the second formula, this one, B bar should be equal to 3 times D bar minus A bar divided by 2. All right. Now comparing these two formulas, what I get is 2 times E bar minus O bar is equal to 3 times D bar minus A bar divided by 2. Take 2 on the other side and you get 4 E bar minus 2 O bar is equal to 3 D bar minus A bar. Now let me connect these A and points A and E, O and D. Okay, so now I can see that if I can see that because these two formulas are same, I want O and D together. So let us bring O and D together. I will have to take this on the other side, on the left hand side, on the right hand side, and A will come on the left hand side. So what I get is, this formula gets modified to, this formula will get modified to 4E bar plus A bar, and on the other side there will be 3D bar plus 2 O bar. Now if you watch closely the coefficients, if you add up the coefficients of both left hand side and right hand side, it is 5. So let us divide both sides by 5. Now this left hand side can be written as 4E bar plus A bar divided by 4 plus 1. Right hand side can be written as 3D bar plus 2O bar divided by 3 plus 2. Now both of them are section formulas. The one on the left hand side says that there is a point which is dividing AE in the ratio 4:1, right? Whereas the other formula on the right hand side, it says that there is another point which is dividing AB, which is dividing OD in the ratio 2:3, right? 3:2, sorry, 3:2. So this point is none other than point P. So I can say that determine, the question they have asked is what, determine the ratio OP as to PD. So I can clearly see OP as to PD is 3:2. That is the answer. Next question. Okay, for this question you first need to remember the row transformation method. Okay, for that you need to remember this formula: A into A inverse is equal to I. Now let us say this is A, so I can write this as cos x minus sin x 0, sin x cos x 0, 0, 0, 1 multiplied by A inverse is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now step 1. I want to make this first element, I want to convert this first element into 1. So for that, I will multiply row 1 by cos x, and I will add row 2. I'll multiply row 2 with sin x as well and add it. And this entire thing I'll be saving in R1. So what I get is cos square x plus sin square x. I'm sorry, cos square x plus sin square x. The second element will be r1 times cos x, so minus sin x into cos x, minus sin x into cos x, plus r2 into sin x into cos x, so that will give me sin x into plus sin x into cos x. The third element as it is will be 0, and the third row will also be equal to 0 0 1. The second row will remain as it is, which is sin x cos x. Now I can modify this by saying cos square x plus sin square x is 1. So let me write here 1 directly. Next, this will become 0 because they will cancel out each other. So this will become 0. Let me write it closer. Okay, below this is cos x, below this is 0. Okay, and this third column will be 0 0 1. This will be 0 0 1 times A inverse is equal to, on the other side, what I get is 1 multiplying first row by cos x will give me cos x. Here the other two will remain 0, and if I add the other, if I multiply the second row with sin x, only this middle element will become sin x and will be added to the first element of second element of this row, first row. So that should be 0 plus sin x, that is sin x. So let me write here sin x. Rest everything will remain as it is. So this will be 0 1 0 0 0 1. Now for the next step, what I will do is I will now I want to convert this into 0. So for this I will multiply first row by sin x, and I will subtract it from the second row. So I can write this as r2 minus r1 times sin x. If I do that, what I get is, I'll write it over here. What I get is sin x minus sin x, so this will become 0, second row. First row will remain as it is, 0 1 0 0. Second row will get converted into, this will be 0, second, r2 which is cos x minus r1 times sin x, 0 into sin x, nothing, no change, it will remain cos x as it is, and then 0, and the other last row will still remain as it is, times A inverse is equal to, here what will happen is, I'll be multiplying the first row with sin x. Okay, so the first will be cos x multiplied by, it will be cos x multiplied by sin x, and 0 minus cos x multiplied by sin x will be minus cos x sin x. All right, next, sin x will be multiplied by sin x, so it will be sin square x, and 1, this is 1 minus sin square x will be cos square x over here, 1 minus sin square x, remember fundamental formula. And the third element will remain as it is, it will be 0. First row will be cos x sin x 0, and third row will be 0 0 1. That's it, we have almost completed the problem. Now all I have to do is I have to convert this cos x into 1, so that I will get here identity matrix. For this, the step that I'm going to use is r2 divide by cos x. So if I divide second row by cos x, this will become I, this entire matrix here will become I, right, identity matrix. Next, besides I there is A inverse, so A inverse will remain as it is, and on the other side what happens is the first row will remain as it is, which is cos x sin x 0. The second row, If you divide by cos x, you will get minus sin x. Cos square x divided by cos x will be cos x itself, and 0. And the third row will be 0, 0, 1. So this should be the answer for A inverse. Alright, so this is the first step. This is the second step. And this up here is the third step. Next, if the angle between the lines represented by ax square plus 2hxy plus by, okay, what you do is first remember the formula of tan theta. It is 2 times h square minus ab upon root of h square minus ab upon a plus b. H square minus ab divided by a plus b. Okay, now what you're going to do is you're going to find the tan theta for both the lines, the first one and the second one. This is the second one. So for the first one, tan theta will be equal to this, whatever we have written. That will be the formula for first one. For the second one, tan theta will be equal to a is in place of a, I will write 2. In place of h, I will write 5. So I know that 2h is equal to 5. So h will be equal to 5 by 2, right? I'm going to compare with ax square plus 2hxy plus by square is equal to 0, by the way. So if you compare this equation with the one that we have got, this equation 2x square minus 5xy plus 3y square is equal to 0, what we get is a is equal to 2. We'll get a is equal to 2, we'll get b is equal to 3, and we'll get 2h is equal to 5, which is what I have written over here. 2h is equal to 5, so h is equal to 5 by 2. Now if I substitute it in this formula, h square minus ab will be 5 square by 2, that is 25 upon 4 minus ab. What is ab? 2 3s are 6, divided by a plus b. A plus b is what? 5. So if you solve this formula, what you will get is 25 minus 6, 24, 1 upon 4. So this will give me 2 multiplied by root of 1 by 4 is 1 by 2 divided by 5. 2 gets cancelled. So tan theta, what you get is 1 over 5. You will get tan theta as 1 over 5. Now we know that the angle between both the lines is equal. That means this tan theta and this tan theta are same, which means right hand side should be same as well. So 2 times square root of h square minus ab divided by a plus b, which we got from this part, will be same as 1 by 5. Square both sides, you will get 4 times h square minus ab divided by a plus b the whole square is equal to 1 over 5 square is 25. Take 25 on the left hand side and take a plus b the whole square on the right hand side, and you get your answer. You will get 25 times 4 will be 100. So I'll write here 100, and this a plus b the whole square will go on the other side to give me 1 into a plus b the whole square, that is a plus b the whole square. Hence proved. Okay, let's start with section D. The first one is differentiate y is equal to log of this. Take log on the other side. That should be the first step. Simple. So e raised to y will be equal to square root of 1 minus sin x divided by 1 plus sin x. Next, the second step will be do not differentiate just now. What you do is multiply and divide by root of 1 minus sin x. Okay, it's kind of rationalizing. Okay, so what I'm going to do is I'm going to divide and multiply by root of 1 minus sin x. So if you watch closely, the denominator gets converted into 1 square minus sin square x the whole root, and the numerator gets converted into 1 minus sin x the whole square. Okay, there's a difference between both the terms. 1 square minus sine square x is cos square x. So the denominator you have square root of cos square x, and at the numerator you have 1 minus sine x the whole square, the whole root. The root and the square gets cancelled. You will get 1 minus sine x, and in the denominator again cos square x and root both will get cancelled to give you cos x. Now you can separate the denominator. You will get 1 upon cos x minus sin x upon cos x. This gives you the final form of the question, which is 1 upon cos x can be written as sec x, and minus sin x upon cos x can be written as tan x. Now you can, this will be equal to e raised to y. Now take e on the other side again. You will get y is equal to log of sec x minus tan x. Now the derivative is very simple. dy by dx is equal to log of sec x minus tan x is 1 upon sec x minus tan x times d by dx of sec x minus tan x. Derivative of sec x is no, I think I should leave it to you. It is very easy, and you can find the derivative of sec x minus tan x, put it at the numerator, divide it with sec x minus tan x. This is the answer. Let's move on to the next question. Examine the function for maxima and minima. Here what I'm going to do is, I'm first going to take first derivative of f of x, that is 3x square minus 9 to the 18x plus 24. Next I'm going to equate this equation with 0. So I can take 3 common. I'll get x square minus 6x plus 8 is equal to 0. Alright, now this is a quadratic equation, and you can find the roots as x minus 4 and x minus 2. Okay, so this gives me two values of x. Let us take x1 as 4 and x2 will be equal to 2. These are the two values of x. Now what I'll do is, I'll take second derivative of the function. Let me take it on this side and with different color. So f double dash of x will be equal to, it will be derivative of this f dash of x, that is 6x minus 18. Okay, now I'm going to do is, first I'm going to substitute the value of x1 over here and check if the value is positive or negative. If I substitute x is equal to 4, I'll get 6 4s are 24. 24 minus 18 is 6. 6 is positive, which means at x1 is equal to 4, you are getting a minima. You're getting a minima. When the value is positive, you get minima. When the value is negative, you get maxima at that point. If you substitute x is equal to, so at x is equal to 4, f double dash of x is equal to 6. At x is equal to 2, f double dash of x is equal to 6 2s are 12. 12 minus 18 is minus 6, negative, which means there is a maxima at, which means there is a maxima at x is equal to 2. That's it. So that's all to this question. Let's move on to the next question. Okay, let me copy this question from my this is the question. C, Control V. All right. Okay, simplify the given expression using statements of logic and draw simplified switching circuit. All right, now what you're going to do is, for this, it's a very simple question. First of all, I don't know why many of you have written the answer incorrect for this. Can you see this second term? Apply what you can do is, many students have used I don't know, De Morgan's law over here. I don't know why you have to do this. You just have to take this second term on the other side, and so negation p you can take on the other side first. Negation p, next p and q, you can swap the inputs, or p and negation q. Once you have done this, if you watch closely, you have p and, for both the terms you have p and take P and common. So you will get P and what remains in the bracket is Q or negation Q, isn't it? Now we know what is Q or negation Q. If one of the two inputs, if one of the two inputs is, if any of the inputs, in fact, if any of the inputs is opposite to the first one, and we have an OR logic, then the answer is always true. True. So it will be negation P or P and true. True is like multiplying with 1, and true means multiplying with 1. The answer will be P or negation P. And you know what is P or negation P? Again, same thing. These are opposite inputs connected by an OR. Opposite inputs connected by an OR will give you a true. So the answer is true, which means the switch will always glow. The switch will always be closed, which means the bulb will glow. So how to draw the circuit? Here is LED. Here is the battery, and the switch you have to close. So S will be always closed. And now just connect this. That's all you have to do. Let's move on to the next question. Next question is, again I'll have to copy. This is the last question. Prove that the line segment joining midpoints of adjacent sides of quadrilateral is a parallelogram. All right. Okay, for this question, let's draw the diagram first. There is a quadrilateral. Let us say this is a quadrilateral. This is A, B, C, D. I'm taking midpoints of all the lines of this quadrilateral, all the sides, and I'm going to join them. Let me join it with another color. This will be okay. Okay. Let it be P, Q, R, S. All right. So I have to prove that. I have to prove that quadrilateral PQRS is a parallelogram. That is what I have to prove. Okay. So let's start with whatever data we have. P is the midpoint of AD. If P is the midpoint, P is the midpoint of AD. If P is the midpoint of AD, P will be equal to A bar plus D bar divided by 2. Similarly, Q is the midpoint of AB. So I can write Q bar is equal to A bar plus B bar upon 2. Similarly, R is the midpoint of BC. So I can write R bar is equal to B bar plus C bar upon 2. And finally, S is the midpoint of DC. So I can write S bar is equal to D bar plus C bar divided by 2. All right. This is clear. Now I want to find out PQ bar. Let us say PQ bar is like this from P to Q. So PQ bar should be equal to Q bar minus P bar. We know what is Q bar, we know what is P bar. So what will be PQ bar? It will be A plus B upon 2 minus A plus D upon 2. A will get cancelled and you will get B minus D upon 2. This is half of dB bar. Okay. Now find out SR bar. What will be SR bar? Can you guess what will be SR bar? It will be R bar minus S bar. And what will be R bar minus S bar? R bar minus S bar will be, again, it will be same. It will be half dB bar. Just substitute the value of R and S from these two equations, simplify, and you will get the same answer. It will be half dB bar. This is an indication that PQ bar is equal to SR bar, which means PQ and SR are parallel, PQ and SR are parallel and they are equal. Similarly, we can prove that the other two sides which are opposite, SP bar and RQ bar, they are also equal and parallel, which means the opposite sides are equal and parallel. Hence, we can say that PQRS is a parallelogram. That's it.